Hello everyone, welcome back. In this video, I will be covering section 3 of chapter 3, derivatives of trigonometric functions. Earlier in the two sections, 3.1 and 3.2, we saw various derivative rules. We saw derivative of polynomial functions, derivative of exponential functions. We saw power rule, sum, product, quotient, difference, and so on. Now, in this one, we are going to focus our attention on trigonometric functions and their derivatives. So before we get to the details, we need two formulas that we quite often use, even to prove a derivative of sine x equal to cosine x. So limit as theta approaching 0, sine theta over theta equal to 1. Or if you graph sine x over x in your graphing calculator, and then in the neighborhood of 0, you will notice that the value is equal to 1. So you notice that this will be equal to 1. Same way, if you graph cosine theta minus 1 over theta, as theta approaching 0, this is equal to 0. These two rules are important to prove even the derivative rules of sine x or cosine x. Derivatives of trigonometric functions. Derivative of sine x is cosine x. We have even seen this one in a problem in chapter 2. We actually drew this as a graph, sine x graph, when we did the derivative graph of sine x in section 2.8 to be specific. And we drew the derivative graph and we found out that the derivative graph of the sine graph looked like a cosine graph. So we did this graphically. Now we are going to do this using definition 1 or definition 2 of the limits. And derivative of cosine x is minus sine x. Derivative of tan x is secant square x. Derivative of cosecant x is negative cosecant x cotangent x. Derivative of secant x is secant x tan x. Derivative of cotangent x is negative cosecant square x. All these rules, all these derivative rules are very, very important because we will come across the rules a million times throughout the calculus course. So now let's at least prove one of them and we'll see how, using the definition of derivative, we are able to prove derivative of sine x equal to cosine x. We did this graphically in section 2.8. We did this problem graphically in section 2.8. Check that one. Now let's use the definition of limit. So what is the definition of the derivative? You can apply either the first definition or the second definition. Maybe second definition will come handy here. So f prime x, assuming that f of x equal to sine x, what is f prime x? Limit as h approaching 0, f of x plus h minus f of x divided by h. What is f of x? Sine x. Then what is f of x plus h? Wherever x is, that must get replaced by x plus h. So this x here must get replaced by x plus h. Put that in parentheses. Will sine of x plus h be equal to sine of x plus sine of h? Can you distribute the sign? No. The sine of x plus h, by trigonometry class, by trigonometry, we know that it looks like sine of u plus v. So it is sine u cosine v plus cosine u sine v. This is the sine sum formula. The formula for sine sum. So applying that to f of x plus h, which is sine of x plus h, which is sine u cosine v plus cosine u sine v. Then I will apply all these here. Limit as h approaching 0. I'm going to now substitute for f of x plus h, which is all of this, which is sine x cosine h plus cosine x sine h minus f of x, that will be just sine x, right? That's given in the problem, sine x divided by h. What is f of x equal to? Just sine x. All right, so now limit as h approaching 0. So we will do some grouping here. You notice that in these two terms, sin x is common, right? So let's take the sin x out and we'll write the rest of them, which is cosine h minus 1 plus the second term that we have is cosine x sine h divided by h. So I'm looking these two, first and the last, and I did this, and then I'm keeping the second term as is. So now you can actually break them into two terms. One is sin x times cosine h minus 1 over h, one term. The other one is limit as h approaching 0, cosine x sine h over h. As h is approaching 0, sin x is independent of that. So it is sin x can be taken outside of the limit because it has got nothing to do with where h is approaching to. Now, the other one, cosine h minus 1 over h plus, again, when h approaches 0, cosine x is independent of it. So it is cosine x times limit as h approaching 0, sine h over h. Now we have first term sine x. What is this limit? This is exactly what we talked about. Cosine theta minus 1 over theta, limit as theta approaching 0 is 1. So if I apply that over here, cosine h minus 1 over h, limit as h approaching 0 equal to 0. Theta replaced by h, that's exactly what we have here. So that will be 0. Plus cosine x times, we know, sin h over h as h approaching 0 is the first one. So if I replace the h by theta by h, so lit as h approaching 0, this will be equal to 1. So this here, second one is going to be 1. Right? So this is 0 and this one is 1. So it becomes 0 plus cosine x, which is cosine x. So the derivative of sine x, right? Derivative of sine x equal to cosine x. Now, earlier we saw in 2.8 graphical method. Now we are seeing it using definition of limit method. We can actually prove the rest of them. Even derivative of cosine x equal to negative sine x can be done same way. You may have to use a trigonometric formula for that. Cosine of u plus v, which is cosine u cosine v minus sine u sine v. That may be used here. the trig formula that you need for the second one, for this one, it's cosine u, cosine v, minus sine u, sine v. You may want to try that on your own, just to make sure that you are following these definition. The next one is proving d by dx of tan x equal to secant square x by quotient rule. So as it says what rule it is, we will write tan x as, from trigonometry, we will write tan x as sin x over cosine x. Then we'll apply quotient rule. So the numerator can be treated as u, the denominator can be treated as v. Then we have d by dx of u over v, quotient rule. So it is v u prime minus u v prime over v square. So what is u prime here? Derivative of sin x, which is cosine x. What is derivative of cosine x? Which is negative sin x, right? We saw both in the first two. So we will use them for in finding derivative of tan x. So what is v? Cosine x. What is u prime? Also cosine x. Minus u. What is u? Sin x. What is v prime? That is negative sin x. Divided by what is v square in the denominator? V square is cosine x the whole square. So derivative of tan x would be cosine square x on the numerator. Minus and minus on the numerator makes it positive, which becomes sine square x over cosine x the whole square. By Pythagorean identity, the numerator is 1. So we know that sine square x plus cosine square x equal to 1, which is Pythagorean identity from trigonometry. It is 1 over cosine x the whole square, or it is 1 over cosine x in parenthesis square. What is the reciprocal of cosine x? Secant x. So the parenthesis, the one inside the parenthesis is after all secant x. Secant x the whole square, which can be written as secant square x. So derivative of tan x is secant square x. Actually, we have proved the third rule, the derivative of tan x equal to secant square x. This is what we proved. We used the quotient rule here. Next, let's compute limit as x approaching 0, x times cotangent x. So how do we find, because it is involving trigonometry, if we write that cotangent x, suppose we apply the limit right away, if we directly plug in. So what will happen? X approaches 0, cotangent is cotangent of 0. So we have a situation here, 0 times cotangent 0 is 1 over tan 0, that is cotangent 0. It's a reciprocal of tan. So 1 over 0, which means it's infinity. So 0 times infinity is it's an indeterminate quantity. Indeterminate. So we cannot keep the expression as is. So let's do some algebra here before we get to the limit as x approaching 0. X times cotangent x is x times cosine x over sine x. Cotangent x is cosine x over sine x, right? Cotangent x is cosine x over sine x. That's what I'm using. And also I'm going to make use of the fact that sine x over x equal to 1 when limit as x approaching 0. We are going to use that fact. So I have something like that here. So I can write this one as cosine x over sine x. I can move this x and bring it to the denominator of the denominator. So make sure that it's okay. So what is cosine x over sine x over x? So it is cosine x over 1. If you flip and multiply, you get x over sine x. So on the numerator, you have x times cosine x, which is what we have here on the numerator. Just this. On the denominator, we have sine x. Right? So we can definitely write this expression as cosine x over sine x over x. Now, if I apply the limit as x approaching 0, which is x times cotangent x, that's what the question is. So I'll have limit as x approaching 0 of cosine x over sine x over x. So I can apply the limit for the numerator separately and the denominator separately. Divided by limit as x approaching 0 sine x over x. X approaching 0 of cosine x. So you can directly plug in there. The denominator from condition 1 from 1 is equal to 1, right? This value equal to 1. So the denominator is 1. What is cosine 0? 1. Denominator is 1. So the value of the limit is equal to 1. So what do we conclude? Limit as x approaching 0, x times cotangent x equal to 1. All right, let's try a couple of problems from this handout, additional suggested problems. So in this additional exercise, there are some star problems, which are homework exercise. Whichever says PT, that means they are found in the practice exam. So I've also done some videos for problems. Some of them you can find them there too. So we will do some of them here and some of them you can find in the chapter videos. So let's try problem number, say 15, which has a numerator and the denominator. Okay. Y equal to x over 2 minus tan x. So this clearly is a quotient form. So we can apply quotient rule to get the derivative. So we have find the derivative of we are finding y prime. So what is the first step? Recognize u and v. The denominator is v. So we will write them down. U equal to x, v equal to 2 minus tan x. What is u prime? The derivative of x, which is 1. What is v prime? Derivative of 2, 0. Derivative of tan x is secant square x, but there is a minus sign in front. So you remember this table? So it's better to memorize this table. So derivative of tan x equal to secant square x is what we used in this problem. So what is y prime? Which is d by dx of u over v. So it is v u prime minus u v prime divided by v square. What is the denominator? 2 minus tan x times u prime, which is 1, minus u. What is u? U equal to x. What is v prime? Negative secant square x divided by v square, which is 2 minus tan x, the whole square. So y prime, if we can simplify, we will simplify. Otherwise, we will just keep that way. It's x times secant square x, because minus and minus makes it positive, divided by 2 minus tan x, the whole square. So nothing much we can do with this problem. We cannot simplify that any further. So we will leave the answer the way it is. Let's try number 29, which is also on the practice exam. Find the equation of the tangent line to the curve y equal to e to the x cosine x plus sine x at 0, 1 at a specific point. So we are going to do number 29. Find the equation of the tangent. So whenever we want the tangent, we need the slope. We need a point through which it passes through. The point is given to be 0, 1. So we need to find out the slope. So we did a problem earlier. The slope is nothing but the derivative at a specific point. The point is taken as x equal to 0. So first, to find the slope of the tangent, m of the tangent, we will do dy by dx. So it is derivative of e to the x cosine x plus derivative of sine x, right? So we have to do derivative of e to the x cosine x plus derivative of sine x. So this derivative of e to the x cosine x is made up of product of two functions. So now you have to look at this one as u, this one as v. For the second, not a problem. Derivative of sine x is cosine x. Only for this part, okay, d by dx of, we have u times v kind. What is u? Which is e to the x. What is u prime then? E to the x also. V is cosine x. What is the derivative of cosine x from the table? That is negative sine x. What is the derivative of cosine x, which is negative sine x? So you have to kind of memorize that table. So we know all of it. So dy by dx that is asked in the problem is d by dx of u times v. So I'm going to use the product rule here. Just product rule. U v prime plus v u prime. And the second term, we'll just keep it the way it is, cosine x. So we get e to the x is common in the first two terms. If I write the positive term first, it will be cosine x, negative term after, plus cosine x. And this is our dy by dx. But what is the slope of the tangent? M, right? Slope of the tangent. That is going to be dy by dx evaluated at a specific value of x, which is 0 here. Why is 0? That is where we are drawing the tangent. So you have to take the x coordinate of that point. So remember that slope will always be a number. It will not be in terms of x. So it will be e to the 0. So I'm plugging in 0 in this dy by dx, right? In this dy by dx, I'm plugging in 0. So it is e to the 0 cosine 0 minus sine 0 plus cosine 0. So 1, cosine 0 is 1, sine 0 is 0, cosine 0 is 1. So it is 1 plus 1, 2. So we got the slope equal to 2. Slope of the tangent line, that is equal to 2. And it passes through the point 0, 1. So equation of the tangent passing through 0, 2, is it 2? 0, 2, 0, 1, passing through 0, 1 with the slope is y minus y1 equal to m times x minus x1. So y minus, what is the y coordinate? 1. Slope is 2. X minus, what is the x coordinate of the point? 0, right? So we get, so it is x1 and y1 so we get y minus 1 equal to 2x. So if you move the negative 1 to the other side, you get 2x plus 1. That is the equation of the tangent line at the point 0, 1. All right. Let's try this limit problem, 46. Limit is x approaching 0, sine x over sine pi x. So when we evaluate the limit is x approaching 0, sine x over sine pi x, there are a couple of things to note. So earlier when we said, we know that sine theta approaching 0, sine theta over theta equal to 1. We have been using that in many problems now. So obviously, limit as x approaching 0, sine x over x will be equal to 1. When x approaches 0, any constant multiple of x will also approach 0. Pi is after all a constant. So we can make an assumption here, sine of pi x over pi x. So whatever be this variable, that is what you should see below, right? So that same thing, then with the pi x approaching 0 should also be equal to 1. So using this, now we have to do a little bit of algebra here. So sine x over sine of pi x equal to, I'm going to divide the numerator and the denominator by x. So I'm going to divide the numerator and the denominator by x. So I'll have sine x over x on the numerator. I'm dividing the numerator and the denominator by the same quantity, divided by sine pi x over x, correct? The numerator poses no problem, sine x over x, but the denominator, so you know that sine pi x over pi x, if you look at the step, sine pi x over pi x, when pi x approaching 0 will become 1. So we need that pi x in the denominator. So you multiply and divide this expression by pi. Okay. So now what happens here? So I have sine x over x, and then I'll have sine pi x over pi x, then times pi in the denominator. Now I apply the limit. The limit is x approaching 0, sine x over sine pi x is limit as x approaching 0, sine x over x divided by sine pi x over pi x. Keep in mind, pi is only a constant. When x approaches 0, pi x will automatically approach 0 times 1 over pi. So it is limit of the numerator and limit of the denominator times 1 over pi. It is okay to assume that pi x is also tending to 0. So the numerator is 1. From what we stated here, sine x over x is 1, limit as x approaching 0. Sine pi x over pi x when x approaching 0 is also 1. So this is also 1 times 1 over pi. This is equal to 1 over pi. So limit as x approaching 0, sine x over sine pi x equal to 1 over pi. Let's try another problem where we have product of 3 functions. If you look at problem number 22, the question is asking us to find the derivative. This t e to the t cosine t. So it's product of 3 functions. So how do we extend the product rule to product of 3 functions? So it is something like u, v, w, right? This is u and v and w, right? So what is the product rule that we have seen before for two functions? So a derivative of u times v is the first derivative of the first times the second, the derivative of the second times the first. So at a time, you take the derivative of one function and multiply with the other. So we'll use the same principle, u, v, w. You're going to take the derivative of the first and multiply with the other two. Then derivative of the second, multiply with the other two. Derivative of the third, multiply with the other two. So it is just an extension of the product rule to 3 functions. Product rule, right? It's also product rule. So now we have u in our problem is t, v in our problem is e to the t, w is cosine t. So what is u prime? Derivative of t, which is 1. What is v prime? Derivative of e to the t is e to the t. Derivative of w, which is negative sine of t. So f prime of t is u prime vw plus v prime uw plus w prime uv. So u prime is 1, v is e to the t, w is cosine of t, and v prime is e to the t, u is t, w is cosine t, and w prime is negative sine t, u is t, v is e to the t. You notice here in every term, we see that e to the t. So we will common factor the e to the t, then we'll write the rest of them, which is cosine t plus t cosine t minus t sine t. So that product rule has been extended to product of 3 functions in this case. The answer is e to the t times cosine t plus t cosine t minus t sine t. So this finishes this section on trigonometric functions. And you have seen these rules here, the derivatives of trigonometric functions, which you need to memorize. And for many problems, when you derive, we used the two limits that are shown on top. So revisit them. And in this, there are some more videos that are done for this exercise. You can find them either in the practice exam or on the chapter videos. That the next section would be on 3-4. So you can follow me for the next section 3-4. Hope this video helps.